Hello YouTube, this is Alexander again. Today I want to talk to you about this ultrasonic cleaner which was given to me by an acquaintance of mine. This kind of device, for the people who didn't know this device, those devices are used to clean some parts with ultrasonic wave. You put water on this container, mix it with a chemical agent or with simply with soap, and you turn on sorry, and you turn on this device, and it produces high frequency wave which use the principle of cavitation for to clean the object, and so this device comes from this device belongs to the professional realm, and it's a very expensive one. This one costs something like $1,450, I think, something like that. It's pretty expensive because this is a professional one. So the acquaintance who gave it to me, this device, tried to attempt a repair, but unfortunately, after finding faulty component inside and after changing this component, this device still doesn't work. So he gave it to me for to take a glance and to see what can going wrong inside and try to make a repair. Because as you see, the made of this device is very nice. This is a very high quality brand. The container is made by stainless steel, which is very solid in the time. And you have here little sewer for to throw by this little valve here the bad water when you need to change it without taking all the device and reverse it on a sewer. So this device is the Elmasonic X-tra 70H brand by Elmasonic, and this is a special brand for building this kind of stuff. And this one is quite simple because it have just a button for to select the temperature of the heat, because this device use heat for to make more results. And here you have the switch on and off for the heating, and here you have a selected power for to select the power and the soft power. And here you have apparently a timer which is faulty here. I think he's inside, and so we're going to see inside what can be interesting to see. You can see here the guts of the device, and apparently some piece here seems to be broken. It seems to be the timer here, and unfortunately a spring is missing inside for to make the timer working, but this is not so important. It's very easy to short this device for to make the device working. And so you can see here the heat sink is missed, because I think the last owner tried to make a repair without mounting the heat sink. And at first glance you can see this capacitor, which have some traces of glue, and I think they was stuck somewhere like this, maybe. The first nice thing we can notice in this kind of device are the transducers, which are here in this very high quality brand. You can see there is three of them, which can provide a very high power of cleaning. So this transducer here are powered by a high frequency transformer. You can see here, this is not a classical transformer. The black part you can see here is a ferrite core, and it's exactly what you need when you have high frequency pulsing. And so you have here the secondary, and you have here separated by a good here it's frankly separated here, as you can see. The primary here is go through this capacitor and go to the PCB, and the other wire here, the blue wire, is the other wire to attack the primary of this high frequency transformer. So here you can see the principal MOSFET for driving the transformer. This is a power MOSFET for the switching power supply. Here you have a Schottky diode, and here this is a simply MOSFET for to switch on or switch off the circuit. Here it reacts like just a switch. So under this timer you will have a little simple transformer with a little rectifier here. You can see here the little rectifier working with this transformer, because the main have its own rectifier, because this MOSFET are connected to the main, and after this bridge rectifier, the filter is just simply this little capacitor, which is not very important here. And after filtered the signal after this coil, it's sent through this transistor, which works exactly like class AB amplifier, and you will have the output of this two transistor going through a capacitor and attacking the coil on the transformer, exactly like class AB with a mono power supply will works. This transistor was the faulty component which my acquaintance have changed, and unfortunately this is not the reason why this device doesn't work, because actually this device is still working now, because we have a good value on this transistor here, and so we need to take a glance with another part. I will use this galvanic protection adjusted on the 150 watts bulb to protect the circuit of this device for trying to find some trouble. And so this fan is running. What we are going to do is to disconnect it. Here the probes are connected on the drain and source of each transistors, and it confirmed to me, because this high voltage, it confirms to me that this stage works like class AB amplifier do, and they work with a capacitor on the line, on the output line, like a class AB amplifier can do too. So this stage here seems to be okay for the check trouble. When you measure 320 volts here, it's because you found the positive on the one leg of the transistor and the ground here on the other lead of the transistor. This is the reason why you will find 320 volts like that. Here you have a coil, which is in fact a driver. This driver have a wire coming from the PCB, and it have a secondary, which is double wire here, have a black wire and a white wire. The black wire, this two black wire work together, and the white wire work together too. They are sent to the grid and the source of the transistor for to drive it. Of course, what you need to understand then mandatory this wire command one transistor while the other is not commanded. When the black wire saturated one transistor, the white wire opened completely the other transistor. So this wire works in a special way when the positive saturate one transistor, the positive of the other wire make the other transistor completely open. So you need to understand then, because lots of people have made some trouble checking on this device. I found a wire inverted on the transistor here, and I had to invert this two black wire for to have the corresponding non-phase attack for each transistor here. When a transistor is open, the other is saturated, and vice versa. And when I opened the circuit, I found exactly the opposite, which means the transistor was blocked both in the same time, or was open both in the same time, which is not the good way to work for this device. So I changed mandatory this wire for to have the good sine wave to drive this transistor, because when it's easy to understand, then if you have a positive on the black wire, you will have a positive on the white wire, and you will have the negative on the black wire and the white wire. This is the reason you need to distribute correctly this phase on the grid of each transistor. This way to drive transistor is a very old. This is a very old techniques, but it have a very good advantage. It's you cannot send a bad signal in the same time during for to make the two transistor saturated in the same time, which can make a short circuit, because when you have a positive wave on the wire, you will have a negative wave on the other wire, and mandatory when a transistor is open, the other will mandatory will block it. So this is a very old way to proceed, but this way is one of the best for iterability, for making the device working. Exactly as you can see on the class AB push-pull here, you can see here the same configuration with a capacitor and a coil. Just in this case you have a transformer for the output. I'm going to explain to you why further, but this is a very close configuration between each other. On the schematic here, you will find here the push-pull and the driver, which here, the capacitor and the transformer. As you can see here, you will find the capacitor, the transformer, the two transistor, and the driver. As I explained already, the point of each coil is not at the same place to on the transistor for to give an opposite phase on each, for to permit to one transistor to be blocked when the other is open, and vice versa. And it's very easy to make a push-pull with a transformer driver like that. One of the most important thing here is I rectified this wire because there was connected with the bed way, and you can do anything you want if the wire here are not connected. You cannot make this device working. You absolutely need to make the good wiring on this transistor before to check any faulty component or other stuff on it. You can notice here the transducers, which is 3. It's very amazing to see so much transducers. They are very, very heavy, and they provide a lot of energy to make a cavitation used to clean the piece inside the container. And so the transformer here is made by ferrite core, which is the two coil here is separated by a little clearance. You can see here a little clearance here. So and it works through capacitors. So as you can see here, there is two coil. To be honest, I don't understand really why this first coil is here, but I know that this coil here is the main driver. So if you take a look on this PCB, you can see there is a lot of IC, which is pretty ridiculous, because you know then you don't need all this IC to make a square wave to drive a device like that. Even if you can have a modulation of frequency, because some device like that works with sweeping 30 kilohertz to 80 kilohertz to have a modulation of frequency to make a better result of cleaning. So I don't really understand why this component, why all of this IC are on this PCB. It seems a very sophisticated device. Here you can see the waveform coming from the driver, and this is behind the driver, because this waveform is picked up on the PCB, and you can see it's switching switching frequency about 35 kilohertz, and you can see the square wave coming from this PCB, which indicates that the main board is not dead. I'm just wondering what is this stuff? A buried wire, soldered and hidden on the little tube, which I don't really understand what all these things means. And if you look, the color, the brown and red, it comes from the same sense. Apparently some connection is missing here, and if you look the square wave, you can find the square wave on the brown wire and the red thick wire, and it doesn't go to the coil. So what I'm going, after discovering this little wire, I'm going to inject the square wave directly to the coil by making little contact here, and see what's happened. I just connected the bad wire to the probe to use this very sharp probe. and so it seems to work. But if you, it uses lots of power, because when it's switched on, you can see the light coming from my galvanic protection transformer, as you can see. You can see the lights. So what we're going to do is just to connect this stuff on here. I don't really understand why this bar copper is doing here, but anyway, so the main thing then it's working, and try, and okay, let's connect this stuff on this wire. To prevent any bias or polarization with a DC current, I prefer to use a little capacitor on the line like this for to connect the missing wire to a suggestive connection for to make it working. Okay, it's like a mystic repair. I'm going to put a little heatsink to replace the missing heatsink, and this pattern to isolate the transistor, because they have metallic shape, and it can be dangerous if you don't use an isolated pattern like that. I just raised this transistor like that for to put this sink like that, if I can, of course. Now the heatsink is mounted, and you can see here the protective gloves, if I can call it like this, and you can see here the little piece of plastic which maintains the transistor against the heatsink. So all of this stuff are isolated, of course, to work properly. So what I'm going to do here is to remove this timer, because he's very broken, and I have no parts or any solution to fix it. So what I'm going to do is to short circuit this timer and use the button of the heating element to switch on or switch off this device, because the heating element have a sensor inside, which is, when it's on minimal position, it's switch off the heating, as you can hear here. It's switch off the heating element. So when the button is like vertical like that, it's absolutely switch off the heating element. Anyway, if you no matter if this switch is on or off. So I'm going to use this just this knob to switch on or switch off, and use this switch to switch off and switch on the anterior device. and it seems to be working at first glance. Now there is some water on it, and let's switch on. Let's try an aluminium foil inside and see what happens. This is what happened after 1 minute on this ultrasonic cleaner for an aluminium foil. It totally destroyed by 1,000 of little straw in the paper foil, the aluminium foil. So this is the proof that this cleaner works now. Okay, that's all today. I hope you like this video, and I'll tell you, see you soon. It's even able to remove the rust on this plier.